4.3, Graphing Functions, Part 2, I'm going to do another function that happens to be a rational expression. So first thing I'm going to do is check for even, odd, x integers and x intercepts and y intercepts. So first off, if I check even and odd, this one actually, this will be neither also. If I want to find the x-intercepts, I plug in 0 for y and I solve for x and I get the point 0, 0. If I find the y-intercepts, I'm plugging x in for 0, 0 in for x and I get 0, 0 also. So the only place that this graph is touching the x-axis is at 0, 0. But I also have to deal with something else because it's a rational expression. I have a vertical asymptote when the denominator is undefined. So I'm going to have an asymptote when x equals 2. So I have to take that into account when I'm sketching my graph because of the rational expression. So from here, I'm going to go ahead and take the first derivative, and it's going to need the quotient rule. So it's going to be low d high minus high d low all over low squared. I'm going to go ahead and simplify this expression, and I should get x squared minus 4x over the quantity x minus 2 squared. I'm going to go ahead and set this equal to 0 to find my critical points. And when I set this equal to 0, I end up with x squared minus 4x equals 0. 0 product property, I see that I have 0 and 4 are my critical points. From here, I'm going to go ahead and do the second derivative. Now, the second derivative is going to be quite involved and it's going to be really tight in this space. So I'm going to go ahead and try to take this expression here is what I'm going to use for my second derivative. It is going to be the derivative of low d high minus high d low, which is going to be power rule. And then this is all going to be over the low quantity squared. This one does simplify out. I did multiply through, I expanded this first binomial, and then I did multiply that by this second binomial. I did combine all of these for the second term of the numerator, and then what happens is I end up getting left 8x minus 16 over the quantity of x minus 2 to the fourth. So for the second derivative, finding critical points, I'm going to set that equal to 0 and solve for x. I get it down to 8x minus 16 equals 0, x equals 2. So now I have these different sets of critical points. I'm going to do something that I didn't do in part 1. I'm going to use these critical points and do the second derivative test. Remember, the second derivative test is I'm plugging the critical points from the first derivative into the second derivative to find max and mins, my extremas. So I'm going to use the first derivative critical points, substituting it into the second derivative function, and I see that when I do this, I have a value of a -1, and remember second derivative test, if this is our -1, this is our local max. And if I plug 4 into our second derivative, it equals 1, and then this will be our local min. If these are our local max and min, I'm going to go ahead and stick this x coordinates into my original function and evaluating so that I get 0 and 8. So my point 0, 0 is going to be my max, and the 0.48 is going to be a min. So those are two things I have there. And then I need to go ahead and do the interval testing that we did from our first and second derivatives. So I'm going to go ahead and do my interval line for my first derivative, and I'm going to have the values 0 and 4. I'm going to test this intervals. I'm going to do -1. Second interval, I'm going to do 1. And the third interval, I'm going to plug in 5. Remember, I'm going to check for increasing or decreasing when I evaluate. Plugging these values into the first derivative, I see this interval is positive, so it's increasing. This interval is negative, decreasing. And this interval should be positive. So I should be going increasing, decreasing, increasing. All right. But using our second derivative, I'm going to check for inflection points. And we said we had a value of 2 for our inflection point. So in this one, I'm going to evaluate into the second derivative 0, and some other value on this interval that I used was 3. Remember, I'm going to check for positive and negative, and this is going to tell me concavity. When I plugged in 0 into the second derivative, I got a negative, so this is a concave down. And when I plugged in 3 into the second derivative, it was positive, and this is going to be concave up. So this definitely is an inflection point of some sort, I think. We have to go back to our very beginning and see what we were doing up at the top. We said that it was not even or odd. We said the only place we were touching the x-axis was 0, 0. And this is the key right here. We had an asymptote at x equals 2. So now, this is not really an inflection point then. I have an asymptote here. So I'm going to write through my little intervals. It's not an inflection point, it's an asymptote. So this then changes this here, this graph, part of my function. I was negative on this interval, and I'm negative on this interval, but I'm going to have a different looking graph because of the asymptote. So that's something we really had to pay attention with because of the rational function. So when I go ahead and I start sketching my graph, we said we had an asymptote at 2. We said we were only touching the x-axis at the point 0, 0. We said that we were going to be increasing until 0. And then once we hit 0, we had a max point at 0, 0, and then we were decreasing. So I'm going to be approaching this asymptote. Let's double check that we had a max point at 0, 0. Yes, max point at 0, 0. So the other part of the graph then, we can see from our interval testing, we were still negative on this part of the asymptote. And then I said I had a min at 4, 0. Is it 4, 0? No, 4, 8. I'm sorry. So at 4, 8, we had a min. And then after 4, I was now increasing function. Remember, we were concave up. So this is going to have to be what my function looks like. So if we follow all the properties, that we had tested, first, second derivative test, everything else we've tested with the function, we were able to give a sketch like this, and this was our answer for the sketching this curve.